Where does all the water go when it rains? We're going to talk about that this week. Don't forget that red slides are where you have to take notes. You should have your notes handout ready to go. Don't forget to look for the owl and let me know where he is. And remember to fill in all of this stuff that you see here. Okay, so take a look at these pictures here. What do they all have in common? We have some hydraulics going on here, right? We have, I love this picture here, right? Hydration, the key to marathon training. So he is hydrating himself, clearly a marathon runner. And we have, what is this? This is a hydroelectric power plant. Well, hopefully you get the idea. Hydro equals water. We need to talk about the hydrologic cycle, or what you might have called the water cycle. So, my guess is that you probably know a lot of these, but there's maybe a couple in here that you don't know. So, we have evaporation, and by the way, you should be filling these in your notes. We have condensation when it gets to the clouds and turns back into liquid. We have precipitation when those water droplets get too heavy and start to fall to the ground. And then we have surface runoff, which is the water forming rivers and streams and running off into lakes and eventually into the ocean. And we have what's called transpiration. And my guess is out of all of those, that may be the one that you don't know. Transpiration is just the water that comes from plants, that basically evaporates out of plants. And a lot of the water that's in the atmosphere comes from that. Um, is this a Tygon or is it a liger? First of all, this is a real animal, and it is the crossbreeding of a tiger and a lion, or possibly a lion and a tiger. It depends, what you call it depends on whether the male was the lion or the female was the lion. Anyway, could be one or the other, the tigon or the liger. Why am I talking about this? Well, this is an example of taking two words and kind of mashing them together, right? We need a word here to mash together the idea of transpiration and evaporation. And so the combination of all the water that's going into the atmosphere, that's called evapotranspiration. It's the two words put together. So this is all of the water going into the atmosphere. We just can kind of combine that into one thing, evapotranspiration. All right, a watershed. This is kind of the main focus of what we're talking about this week, watersheds. This is the region draining into a river. This is, let's make this clear here. This is an area of land. I know it has the word water in it, but it's an area of land where all of the water that falls from the sky, all of the rain, all of the precipitation, will all drain into one river system. So you can see that all of the water that lands in this area, within this little boundary here, anything that's within this boundary, because of the shape of the land and the hills and the mountains and all that kind of stuff, all of that water is all going to feed in to this area. So all of this area in here, within this circle here, we would call a watershed. Here's another nice little image of it, generally speaking. So we have all these hills that kind of border this valley area. And so when it rains, all of this water, you could guess, kind of like water going down a sink, right? It's all going to kind of drain into one area because of the shape of the land. It's all going to kind of drain towards that area. And it's all going to feed into one river system. So here's a picture of the United States. And I want you to notice something about this in particular, and that is that in this large area here, and in this large area here, we have some mountains, right? So I want you to think about what we were just looking at before and think about a very large scale general watershed system here. Okay, so if it rains in this area right here, and all the water kind of falls on this side of the mountains, well, it's going to feed into river systems over here that's eventually going to lead you off into the Pacific Ocean. But if it falls just a little further to the east and lands over here, we're going to fall and maybe hit this river system here and maybe get to this river system here, and it's going to go down into the Gulf of Mexico. And same thing with if it falls here, it's going to drain into the Gulf of Mexico. But if it falls a little further east, well, it's going to kind of drain into the Atlantic Ocean over here or this way or something like that. So it is really the mountains and the valleys that kind of determine these watersheds. So if we're looking at a mountain like this, and this is part of that, let's say that mountain range that's on the west coast there that we were just looking at, any rain that falls on that side is going to drain down that way, and any rain and it's going to end up in the Pacific Ocean. But any rain that falls on the right side of the mountain, as we're looking at it here, is going to drain that way, and it's going to end up in the Gulf of Mexico. So you can see that just a little bit of a difference in where it falls is going to make a huge difference in where it ends up. So here's another way that you could look at this. Here we have basically 3 watershed areas. And remember, water flows downhill, and you're going to get your river systems kind of towards the bottom of these mountain areas in these valleys, because the water is all going to kind of drain and collect in those areas. So you have, in this situation, when we look at this, if we look at where the mountains and valleys are, we would say that we have one watershed area here where all of that water is going to drain into this river here, right? And we have another watershed over here where all the water is going to drain into this river here. And we have another watershed here where all of this water is going to drain into this river system. So all of the water from the first watershed is going to end up in this area, all of the water from the second watershed is going to end up in this area, and all of the water from the third watershed is going to end up in this area here. So let's take a look at the major watersheds of Virginia. That's where you live, right about there, assuming you live in Virginia Beach. That's about where Virginia Beach is. So what I would like you to do is draw in some rivers. They don't have to look exactly like the rivers that I have on here, but they do have to be in similar areas, okay? So draw in some rivers there, draw in some rivers there, and draw in some rivers over yonder. Now, you're going to need 3 different colors here. Hopefully you have some colors. If you don't have colors, that's okay. It's not a big deal, but colors would be helpful here. Okay. We're going to color and label 3 watersheds. Did you get your colors? Like I said, if not, it's not really a big deal. We can just draw borders around these things, but it'll be a lot more easy for you to remember this and picture it if you color these different areas in. All right, so here's one watershed. This is called the Chesapeake Bay watershed, and it's kind of a good name because it drains into the Chesapeake Bay. Usually the watersheds are going to be named after the major river system that they drain into, or the major body of water that they end up draining into, like the Gulf of Mexico or the Chesapeake Bay or the Pacific Ocean or something like that. Okay, so we are part of that. If you live in Virginia Beach, you are part of the Chesapeake Bay watershed. The second one is the North Carolina Sound watershed. And last but not least, we have the Gulf of Mexico watershed, and this is actually the Gulf of Mexico via the Mississippi River. In other words, all of those streams, all of those rivers are actually going to end up connecting to and draining into the Mississippi River first, and then that water is going to be carried eventually to the Gulf of Mexico. So there are the 3 major watersheds of Virginia. So where do the rivers start? Well, the answer to that is they start in the mountains and they flow downhill. And I want you to think about this because in the western part of Virginia, towards the border between Virginia and Western Virginia, we have the Appalachian Mountain Range out there. And so if you were to walk from the western border of Virginia to where we are in Virginia Beach, or ride your bike or drive a car or whatever, if you were to travel from the western part of Virginia to the eastern part of Virginia, you would more or less, on a big picture, large scale, you would be basically walking downhill the entire time. Yes, you would go up small hills and down small hills and things like that, but overall, your elevation would be going down, down, down from west to east. So as we go from the west to the east of Virginia, you're basically going down a long hill. So all the water is going to kind of follow in that direction, and it starts in the mountains and then ends up in the Atlantic Ocean. So let's talk about that journey from the mountains to the ocean and all of the different parts of the river that get us there. All right. So as we do this, you should be filling this in your notes. You should see these little sections in your notes here. The start of the stream, the start of the river, is called the headwaters. This is the extreme upper part of a river. This is the very beginnings of a stream or a river, and generally looks like this picture that you're seeing here. Kind of small, but somewhat fast-moving water. This might come from a natural spring or something like that, or it might just be rainwater that's traveling down this mountainside. And as it kind of picks up some steam, and as you get a few of those little rivers together, you get something like this. Notice what this looks like. It's very fast-moving water, which you should be thinking erosion and weathering and that kind of stuff here. Like, why are these rocks so smooth here? Well, that's because of weathering. And what kind of sediment can this carry? This can carry large sediment because it's got a lot of energy with that fast-moving water. And it's a very rocky kind of terrain with lots of fast-moving water. This is where you would find rapids and things like that. As you kind of get going down that mountainside, things kind of start to ease off a little bit, which kind of gets us into our next section. But you find little guys like this, all these kind of little creatures. These are the kind of things that you would find in the headwaters. And that brings us to the next part, which is this idea of a tributary. So as I said, all these little trickling streams and stuff are kind of merging together and gathering up some steam here and forming larger river systems. And so a tributary is a stream which flows into the main river. It's the smaller stream that is kind of joining up with a larger river. So like this section right here would be a tributary. So here's a nice little picture of a bunch of tributaries here, right? You can see them all merging together and forming one big large river here, coming together here. Here's another shot of some tributaries. This would be the main river system here, and then you have a tributary coming in from the side here, and you can see that the river gets bigger at that point. Now, once we've gotten to that point, we get into our downriver section, and this is going to be sort of the middle part of the river, the section that is still kind of moving kind of quickly, and this is between the headwaters and our next section, which is called the floodplain. This is what the downriver section tends to look like. A lot of good fishing in that area, lots of good fish in that area, good place for little family outings and doing some canoeing and stuff like that. Not the whitewater rapids of the headwaters, a little bit calmer water in these areas. The next section is the floodplain. This is the flat area around the river that sometimes floods, and so this is going to be down near the end section of the river. It's getting towards the end, not quite the end here, but it's an area where the land has kind of flattened out. It's not so steep, so the water is starting to move kind of slowly, and you've had a chance for a lot of these tributaries to merge together, so the river starts getting pretty wide. You get pretty big rivers in the floodplain area, and they tend to flood a lot, as the name suggests. This is what floodplains look like. This is what floodplains look like. These floodplains tend to carry a lot of the small sediment. By this time, the larger rocks have kind of been deposited already. This water does not have enough energy to carry those large rocks, but now you still have a lot of that really small sediment, the clays and the silts that have been picked up at this point. And so you get a lot of that in there. And with that comes a lot of nutrients for plant matter to grow. And where you have a lot of plant matter, you have a lot of food for the fish. And so we can see that right here. This is kind of probably an area that's coming from two different sections. And as I said, you can get some pretty monstrous fish in these areas because there's a lot of nutrients for plants. And when there's a lot of nutrients for plants, there's a lot of food for the animals. Here is Norfolk, Virginia, and this is actually built on a floodplain. A lot of cities are built on floodplains. This might seem a little strange, and obviously Norfolk, you guys probably know that Norfolk floods a lot. Well, that's because it's on a floodplain. So why would you do that? Well, first of all, you're near a large body of water, so this helps for trade because you can send a lot of boats, ships in and out of that area for trading purposes. And also, it's a very flat area, so it's easy to build on that area. So that's usually why they build cities in these areas. It's just a place where a lot of people come together to do their business and things like that, and it's also an easy place to build a city. Last but not least, we have what's called the mouth or the delta of the river. It's kind of called both of those things, so I'm going to give you both of those terms. Either the mouth or the delta. This is where you get a lot of the deposition of sediments at the end of the river. Here is the delta of the Nile River. We've talked about that before. So this is the land here, and this is the Nile River flowing out here, and you can see this very large area here of where all that silt and clay and stuff is being deposited. And we talked about the idea of how so much has kind of built up around these areas because of all that fertile soil and stuff like that, because of all the nutrients being deposited there. There's the Nile River again. There's the city of Cairo, again, built in that area because it's a good place to build a city because you have a large body of water there to do trade and you have a nice flat area. Plus you have a lot of fertile land there to grow crops and things like that. Here's a nice smaller, more close-up picture of a river delta, and you can see very clearly how this river has kind of flowed in all these different directions as it kind of grows and shrinks, and as you get more water and less water, and all of this stuff is being deposited in this area, and you can even see the stuff being deposited right in this area here. So big link to weathering and erosion here. All right, so those are the parts of the river. Let's now talk about how rivers form and the different formations that happen as a result of this, the different little parts of a river. So this is going to be what we were just talking about previously was kind of a big picture. Now we're kind of zooming in on the river a little bit and taking a little bit closer up look here. All right, so first of all, as I said, this all has to do with the process of erosion, which is the process where fragments of soil and rock are carried away, are moved to a different place. And deposition is where those things are dropped off. Okay, so make sure you are filling in the sketch in your notes as we go. Draw some pictures and fill in the blanks for the definitions of these terms. Our first one is called a cut bank, and this is going to be the high steep banks along the edge of a channel. And I want you to look at where these are. So it's this area right here, and it's this area right here. And what is similar about these? Well, the similar thing about these is that the river is turning here. There is a bend in the river there, and a bend in the river there. And as this water is flowing, it's basically crashing into this area, and as it crashes into that, it's going to take with it some of this sediment here and erode it away and take it away. And so that's why you get these really steep areas on the outside part of a turn. And I hope everybody kind of understands what I mean by the outside part of the turn, right? This would be the inside of the turn, right? And this is the outside of the turn over here. So this is where the faster moving water is and where you get a lot of erosion going on. Take a look at this area though here. We're going to talk about this in a second, but notice that there's sort of the opposite thing happening here. Okay, so where are we going to put our cut banks? Well, we're going to put our cut banks on the outside of the curves here. So there's your cut banks. Make sure you fill that in your notes. The water moves more quickly there and erodes the banks away. The next part is what I was alluding to before, and that is the point bar. This is kind of the opposite of the cut bank. It's on the inside of those curves. It's on the opposite side. This is the shallow part on the inside curve of a river where the water slows and drops off its sediment load. So we are getting on the outside erosion. On the inside, because it's moving more slowly, we are getting deposition. It's that area right there. So let's put in some point bars on the inside sections. Next, we have a meander, and we've been kind of talking about these. We just haven't been using the right word here. These are the curvy sections of the river. This is the looping curve in a river formed by slowly moving water. And we'll talk about this in a second, but I want you to note the fact that as a river forms, it tends to get more and more curves in it. And I'll show you this in a second. But you can kind of tell how old a river is by how curvy it is. The more curvy it is, the older it is. All right, now we have these meanders form, right? And so the meander forms because as you have this water going on, it's going to cut away at this area here, and it's going to add to this area here. So you get something where it keeps getting bigger this way, and erosion and sediments keep getting deposited here. So the curve in the river kind of keeps moving in that direction. And so sometimes that happens so much that you end up getting something like what you see in this part 2 here, where the river actually kind of has eroded so much this way that eventually it kind of cuts through here and leaves this high and dry over here. So the next step would be that gets cut off, and this is where we get something called an oxbow swamp or an oxbow lake. And we might even get old channels and what are called river scars and things like that where the water's not flowing there anymore. So
cutting into the bank. See, it's faster going in and up. There it goes.
There goes it's breaking. Look at this one.
And it's creating steep, finding the less steep grade. And now it's coming down with the higher speed to the steeper gradient. It's hitting this one. It's working its way on this wall. And we have a perfect oxbow lake right there. And eventually, this will eat it up and go straight. See how it's cutting back and straightening?
So an oxbow lake, as you saw in that little video there, is a crescent-shaped lake that is cut off from the river that remains when the river cuts a new channel. So this used to be a meander here, but now it is an oxbow lake because it got cut off. This right here is an oxbow lake that's forming. It's about to be an oxbow lake. This right here is just your meander. But notice, right, like right here, you're going to keep wearing away at these areas until they get closer and closer together, and then eventually the river's just going to cut through and go straight. So let's draw in an oxbow lake, and let's also make sure we get our meanders labeled. All right, next part is not really actually part of a river, but it's the part that's around the river, and this is called a riparian area, and this is really hugely important. That's why I'm including this in here. And this is an area of vegetation that grows along waterways, and this acts as a buffer from pollution and erosion. Remember, this is like the idea of planting our cover crop or maybe even our windbreaks, right? This is going to stop that erosion from happening and kind of keep the river in place. And it also really acts as a place for nature, because obviously animals need water, right? So this acts as a place where they can kind of set up shop here, they can have a home here, and it's near a river area. It's actually, you can think of this much like this area right here, you can think of this much like the cities that we build near rivers, right? This is kind of the animal version of a city built near a river. So this is a good corridor for plants and animals where they can have a good source of water and move around freely without being disturbed by things, and they can kind of hide in those forested areas. So let's draw in some trees there, and that's going to be our riparian area. Now, I'm going to show you a little video clip here of what's called a stream table, and we're actually going to do this in class, and you're going to have to be able to recognize these formations as they happen when we do it in class. So make sure you're paying attention to this. This is going to show you basically a sped up version in a laboratory setting of how a river forms, and you're going to see that idea of how the river basically gets more and more curvy and windy as it forms, and I want you to see how that happens. So take a look at this little video clip here. Okay, so what are the kind of things that we need to notice here? Well, first of all, we notice that when the river first started, it's very straight. It's a young river, and so it doesn't have as many curves in it. But as you get, so as the water goes, right, it's going to hit certain things and it's going to change its course a little bit. And if it hits a little rock that's here and moves that way just a little bit, well, it's going to start eroding this area here and kind of start moving back that way. And then it's going to erode that area and start moving back that way and erode that area. And so it starts looking more and more like this, right? Where we get all these curves happening here, and you could see how it eroded these things. So what should we be looking for here? Well, there's our cut bank on the outside of our curve. We have a point bar there on the inside of the curve. You can see where the deposition is happening on the one side and where the erosion is happening on the other side. You should be able to point that out. We have our deposition happening at the end of the river where the mouth or the delta is, and we have all these meanders here that keep getting bigger and bigger as the river gets older and older. These are the kind of things that you should be able to point out when we do this in class. Okay, well, there you have it. We have the idea of surface water. So first of all, we have to understand the idea of the hydrologic cycle. There we go. And that includes evapotranspiration, which is all of the water going into the atmosphere. So that's probably a term that you didn't quite know yet, so make sure you know that one. I think you guys all got the part about evaporation and precipitation and runoff and stuff like that. But the transpiration and the evapotranspiration thing are probably new terms to you, so make sure you know those. And we have a watershed, which is the area of land that where all of the water drains into a specific river or body of water. The three that you need to know for Virginia are the Chesapeake Bay watershed, that's where we are, the North Carolina Sound watershed, and the Gulf of Mexico watershed. We have the main parts of a river, which include the headwaters, the tributaries, the downriver, and the floodplain. And we have river formations, which include things like cut banks, point bars, meanders, the mouth or delta, and the oxbow lakes. And we will do all sorts of stuff with this in class this week, and I will see you there.